A modern international airport requires billions of dollars in continuous capital expenditure just to keep its runways operational and its facilities structurally sound. To recoup those costs, operators charge airlines for landing rights and terminal use. However, regulatory bodies restrict these primary income streams. In India, the Airports Economic Regulatory Authority, or AERA, issues tariff orders, such as the recent CP4 framework, that strictly cap how much an airport can charge for these aeronautical services. AERA is India's economic regulator that determines maximum charges for aeronautical services to prevent monopolistic pricing while ensuring airport viability. With aeronautical fees locked by regulation, operators must find a counter-engine for profitability. That engine is non-aeronautical revenue, the income generated inside the terminal through retail, dining, and passenger services. This dual-axis chart illustrates the financial reality for Mumbai International Airport Limited, or MIAL. As passenger volume reached 55.1 million in the 2025 fiscal year, the superimposed pie chart reveals that non-aeronautical operations accounted for approximately 60% of the airport's total revenue. That 60% slice is crucial. It provides the cash flow diversification and structural resilience required by credit rating agencies, directly contributing to MIAL securing a top-tier CARE AA+ rating upgrade. A mega airport's ability to service its debt and fund future expansion is entirely dependent on its ability to maximize yield per passenger, the total amount of money a traveler spends outside of their initial ticket price. The financial mandate is clear on the balance sheet, but the execution happens on the terminal floor, where physical space dictates passenger behavior. The baseline environment of a modern terminal is dense, visually cluttered, and heavily reliant on static seating. The architecture naturally induces a state of waiting. India's aviation market is projected to reach over 400 million passengers by the end of fiscal year 2025. Yet despite this massive, highly concentrated captive audience, retail conversion rates remain incredibly poor. This terminal map demonstrates the spatial failure. Traffic flow is heavily concentrated along a few direct pathways to the gates, shown in red. As a result, 70% of the physical retail space is bypassed entirely, creating vast, underperforming cold corridors, shown in blue. The behavioral outcome of this layout is severe. Between 80 and 90% of captive passengers walk through the terminal without making a single retail purchase. During flight delays, this structural inefficiency compounds. Long dwell times trap passengers in congested seating areas, generating passive frustration rather than consumer engagement. Operators cannot solve this bottleneck by adding more square footage or opening new stores. They have to re-engineer how passengers interact with the existing space. RARE is an enterprise software solution built to address this specific spatial failure. It acts as an active digital layer that converts unmonetized idle time into retail spend. The system begins with the integration layer. It requires zero new construction, relying instead on existing terminal networks, standard Wi-Fi, LoRaWAN, and BLE. LoRaWAN is a low-power, wide-area networking protocol designed to wirelessly connect battery-operated devices over long distances. BLE, or Bluetooth Low Energy, is a wireless personal area networking technology designed for very low power consumption while maintaining an effective communication range for proximity detection. Next is the content layer. This pushes personalized rewards, augmented reality overlays, and gamified physical challenges directly to the passenger's smartphone or wearable device. Finally, the data and AI layer processes the resulting behavioral feedback loop, giving terminal operators a real-time, predictive map of passenger movement and purchasing intent. These three API layers form a complete commerce multiplier ecosystem, fully operational without expanding the airport's physical footprint by a single square inch. The architecture is designed to break the psychological state of passive waiting. It incentivizes the passenger to get up and move. As the passenger moves, the system simultaneously coordinates back-end logistics. It syncs with courtesy carts, accesses temporary smart lockers, and gate delivery services to ensure that the physical friction of carrying bags does not prevent a purchase. This digital architecture integrates the passenger as a dynamic, active participant within the terminal's retail network. To see how this architecture performs in practice, we have to look at the mechanics of a single targeted microtransaction. The first operational mechanism uses physical gamification to trigger a high-value retail conversion. In a recent case study with Fab India, the Rare system engaged a delayed passenger with a targeted challenge: complete a 3,000-step walking circuit. Progress was tracked entirely through the passenger's own wearable fitness device. Completing the challenge triggers a 25% discount code, which resulted in a 6,000 rupee retail sale that a static environment would have missed. The second mechanism leverages contextual AI and deep Internet of Things integration to anticipate immediate passenger needs based on localized hardware data. In the electronics category, the integration API actively scans device telemetry. When it detects a critically low battery state on a passenger's smartwatch, it initiates a targeted protocol. The AI instantly pushes a 20% discount for a nearby power bank directly to the user. This highly contextual nudge closed a 3,700 rupee sale. By linking commerce to health and immediate utility, these nudges successfully pull footfall away from congested gate seating and drive it directly into the 70% of corridors that historically underperform. Scaling these microtransactions requires a business model that operator boards will actually approve. Rare utilizes a dual-engine revenue structure. It combines asset-light recurring subscriptions with performance-linked success fees. This pie chart breaks down the revenue composition. The single largest segment, shown in purple, is the success fee. The success fee mechanism ties the technology provider's income directly to the incremental sales uplift they actually generate. If the airport's retail volume does not increase, the provider is not paid the premium. For infrastructure operators managing billions in debt, this structure heavily de-risks the integration. They take a split on newly generated revenue, avoiding upfront software costs. Supplementary recurring streams, like data analytics subscriptions and wellness partnerships, ensure short-term cash flow for the technology provider while the long-term sales data matures. This aligns the financial incentives perfectly. Both the technology provider and the infrastructure operator share the exact same objective: increasing the yield per passenger. Expanding our scope outward, we can see that the scale of this untapped opportunity across the entire Indian aviation sector is truly massive. With a projected volume of over 400 million passengers, the captive audience is firmly in place. However, the region suffers from a severe yield gap, with the average per-passenger spend sitting below 15% of global benchmarks. This financial waterfall chart projects value creation using Adani Airports as the primary model. We begin with their projected 94 million passengers for the 2025 fiscal year, generating a baseline retail and food and beverage pool of approximately 1,114 crores annually. Applying Rare's 30% yield uplift to this baseline generates 334 crores in pure incremental revenue. This revenue expansion is achieved entirely through digital behavioral design, requiring zero newly poured concrete. Future infrastructure monetization depends on coding behavioral interactions between captive passengers and the retail environment. Software-driven interaction is the primary lever for high-yield growth.